Okay, here's our lesson on dilations. We are simply taking a shape and making it bigger or smaller. So here is an example of a triangle that has been dilated around the center of dilation. They will give you a center of dilation, which will either typically be the origin or it might be another point. And this shape is going to get larger by a certain amount, which is called the scale factor. So let's take a look at some examples. Your scale factor is the amount that it's going to get bigger or smaller. So if that number is bigger than 1, it is going to get larger. If that number, the scale factor is a fraction, it's going to get smaller. If it's 1, then it wouldn't change at all, because when you multiply by 1, you don't change the number. Okay, so scale factor is either going to get bigger, or a fraction is going to make it get smaller. All right, so here's how we do it. On a graph, if you're given points to dilate from the origin, I'm simply going to get those points and write them down. So here I have A is at 2, -2. I'm going to multiply those coordinates by the scale factor. So here the scale factor is K equals 1.5. So I'm going to take those numbers and multiply them by 1.5 and get the new coordinates of what I'm doing. So 7.5, -4 times 1.5 is -6, and this would be 3. And then now I can just simply plot these new points. So A prime, the dilated, is what you call prime. The pre-image is the one without the marker. The image is with the marker. So we have -3 and 7.5. So this becomes B prime. -6,3 becomes C prime. So now what we've done is made this figure 1.5 times larger, and it is also 1.5 times further. Each point is 1.5 times further from the origin than it originally was. Okay, so here from the origin with a scale factor of 1/3. So we're going to take this image and reduce it by 1/3. So 6 times 1/3 is 2. So that new point's going to be at 2. This point's going to be at 2. This point's going to be at -2 and -2. So we're just bringing them in each by a factor of 1/3. Okay, now we have a scale factor of 1/2. So these 2 points are going to be 1/2 as far from the origin as they are now. So I'm going to take 3, 4, the point 3, 4, and take it times 1/2. Well, half of that is 1.5 and 2. So the new point is going to be at 1.5 and 2 right here. And then the point 96 times 1/2. So 9 times 1/2 is 4.5. 6 times 1/2 is 3. So this is going to become the point 4.5, 3 right here. Okay, and that is dilated. Each point is half the distance from the origin that it used to be. So we can kind of see that. And then also notice the pathway from your point of dilation, the origin, is going to go through both points, okay? So the scale factor, to find it, is always the image divided by the pre-image. So let's remember, image is what you had after the dilation. The pre-image, of course, pre is before, it's before the dilation. So after divided by before. So in this case, the before is the blue, and the after is that yellow greenish color. We'll call it yellow. Okay. So to get this, I can take any coordinate, because if these are similar figures, they're all going to work the same way. So I'm just going to go with B and B prime. So B, the x coordinate is 4. I don't even really need the y coordinate. And this x coordinate is 2. So this went from 4 down to 2. But we're to get the scale factor, we're going to say the yellow goes on top, the blue goes on bottom. Okay, reduce that. 2/4 equals 1/2. So we have a scale factor of 1/2. So from the pre-image, the blue one, to the image, we decreased by a factor of 1/2. So the blue times 1/2 gave you the yellow. Okay, so that's how you do scale factor. Let's try this one. So again, I'm going to just look at this. I'm just going to pick any coordinate, and I'm going to pick the one that is not in question. It's right on the grid. So we're going from image over pre-image. Okay, which is the after divided by before the dilation. So in this case, it went the number without the tick mark. So we're looking here. This is V prime. That x coordinate is 1, 2, 3, 4, 5. It's -5. Okay, and that is the after, so that's -5. The before, -2. So here, -2 gets you there. So its x coordinate is -2, and that's the before. So that goes there. That reduces to 5/2. Negatives cancel out, and now I have a scale factor of 5/2, which is really that's a positive number. I mean, it's more than 1, right? Because that's 2.5. So we could say the blue one times 2.5 would get you the green one. Find the scale factor. The smaller shape is the image. I'm gonna give this a color besides blue. Okay, the smaller is the image, so it's red is image over pre-image. So that means it's red over blue. All right, let's pick a coordinate. We'll do this one here. 1, 2, 3. This x coordinate is 3. This x coordinate is 4. Okay, so the red is 3. The blue is 4. So our scale factor is 3/4. Image over pre-image. So we would have the big blue, the blue one times 3/4 would give you the red one, because we got smaller. So we would expect a number less than 1. All right, here's where it gets a little tricky. Now we're dilating from a location other than the origin. Okay, so, and I'm actually gonna start, let's look at this example first. Dilate this figure from -1, 2. -1, 2. So from this point. So instead of the origin, we're dilating from this point with a factor of 1/2. Okay, so what I'm going to look at is how far away is this from this point, point 16. How far is it from? I've got a grid. I'm just going to count. So the x value is 2, and the y value is 1, 2, 3, 4. That's how far away it is from this dilation point, -1, 2. Okay, I want it to be half that far. So I'm going to take these numbers and divide them by a half. So 2, 1/2 of the current distance would become 1 and 2. So I want it to be 1 in the x direction and 2 in the y direction away. So this point now becomes right here, the point 0, 4. Okay, and now the q is 7. Let's see, from here it is 1, 2, 3, 4, 5, 6, 7, 8 away in the x coordinate. It's none away in the y direction. So the x coordinate is 8 away, the y coordinate is 0. I multiply those by a half and I get 4, 0. So the new point should be 4, 0 away from here. So 1, 2, 3, 4, 0 gives me the new q prime. So these points have been dilated. You can also notice they're going to go through those points. It is 1/2 the distance from the point as the previous, and it will also be half as long. Okay, so that's the gist of how dilating from a different point is, especially in a graph. You're just going to count how far away am I, use my scale factor, and then count where would that put you. Let's try this one now and see. It goes off the graph, so I was kind of trying to avoid it, but we'll go ahead and try it. So let's go with 6. We'll make a 7. We need a 7 here. So the point 7, 7. So how far is it away from 7, 7? So this is the point 6, 5. Okay, so we have to go over 1 and up 2 to get to 7, 7. Or you could say we have to get from the point of origin to B, we have to go down 2 and over 1. Well, we want to go twice that far. So instead of going down 2, over 1 to the left, we want to go down 4 over 2. So I want to go 1, 2, 3, 4 over 1, 2. That's going to put me right here. Okay. A is from 7 down to 3. That is down. So now we're working on A prime. So from 7 to, well, let's do our x's first. From 2 to 7, that's 5. So I had to go down over 5, and then I have to go from 7 to 3. I have to go down 4. So I need to go twice that far. So I need to go -10 and -8. This is how far I'm traveling. So from 7 down -10. So that's going to put me at -3. That's also off the graph. And then from 7 to -8 is going to put me at -1. So I'm going to be something like this. So that's going to be A prime. So here, and if you notice, if I draw this, okay, that's twice as far away from the point of origin. And here, draw that, keep going. This point is twice as far away from the point of dilation. So mainly just counting it out and thinking about what you're doing is the best way to go about that. How far away am I from that dilation point? Use my scale factor to either double or to as a multiple, either go further away or not as far away. All right, hope that helps.